All right, here we go with 517, chapter 5 homework. Okay, figure below, scatter plot, excuse me, reading scores, IQ, test scores for 14 fifth grade children. So we got the IQ test score is the explanatory variable, and the reading test score is the response variable. The line is the least squares regression line for predicting the reading score from the IQ score. If another child in this class has an IQ score of 110, so here's 110, what would you predict the reading score to be? Well, here's the actual score of a student, reading, the actual IQ and reading score of a student. Well, here's what we would predict using the regression line. We come over here, and we would predict, based on the overall trend of the data, a reading score of about 60. All right, let's go to the next one. We'll put several on this one. So let's do 18. See if I can get 18 on there. The slope of the line. So we want to look at the slope of this guy. So I'm going to put 518 right here. We want the slope of the regression line. Now that's my line of best fit, or we call it the least squares regression line. That's the line that we have chosen in this course to be the line of best fit, since there are many we could choose from. So the slope, let's remember the slope from algebra 2 is the change of y over the change of x. We're going to pick these 2 points here. This one here and this one here looks like it's pretty close to the line. And this one, if I go up, looks like it has, this is going to be just kind of a ballpark estimate. We're going to say close to the change of y. So the y, let me go back. I'm trying to go too fast here. This has coordinates 135, comma, and we'll go over here approximately 80. And this point here has coordinates, we'll say roughly 95, about 50. So the slope is the change of y. And so what is this change? Well, that starts up here at 80 and goes down to 50. So that'd be 80 minus 50 over the change of my x's. That goes from 135 down to 95. Now you may have remembered that as y2 minus y1 over x2 minus x1, but it's really just how far up did my y's go and how far over did my x's go. And so that's going to be, what do we got here? 30 over, that's about, count there, 40. So that's my slope. And what were my choices here? The slope of the line is closest to, well, it's not negative, it's not 0, it's closest to 1. Okay, I realize it's not 1, and notice I just kind of approximated these numbers. It's not quite 135. So closest to 1, this is 3/4 or 0.75. So closest to 1 answers that. We really could have answered that without actually calculating it, looking at the numbers, but I wanted to give you a quick little review on calculating slope. Okay, 19. Points on a scatter plot lie close to the line whose equation is y equals 4 minus 3x. Well, I'm going to rewrite that as y equals negative 3x plus 4, because we're kind of used to seeing y equals mx plus b. So I just rewrote the order of this, which is perfectly okay. So the slope, we call it m, and that's the y-intercept. So the slope of the line is negative 3. Okay, number 20. Fred keeps his savings in his mattress. He began with $500 from his mother and adds $100 each year. His total savings y years after x year, his total savings y after x years is given by what equation? So x is the number of years, y, this is number 20, y is the amount saved. Well, the question is, how much has he saved? Well, he started with $500, and for every year he's adding $100. So after 1 year it's 100. After 2 years it's 100 times 2. After 3 years it's 100 times 3. After 4 years it's 100 times 4. After X years it's 100 times X. So if X is the number of years, you multiply that times 100, and then we're going to add it to the 500 he originally started with. So that's going to give me his total savings after X years. And last but not least on this one, 522, we've got measurements on young children in Mumbai, India found the least squares regression line for predicting height from arm span. So I'm going to write we're predicting height from arm span 6.4 plus 0.93. Oops, this is arm span. Those are actually pretty close together. All measurements in centimeters. How much on average does height increase for each additional centimeter of arm span? Ooh, so this is a question really asking this. We've got arm span and height, and we've got a bunch of data here, and here's my regression line going through the middle of it. And what we're really saying is, on average, for each centimeter the arm span goes up, how much does the height go up? Well, that's my slope, isn't it? And isn't the slope 0.93 centimeters? And I can always write it divided by 1 centimeters. And I'm going to be even more specific with my units, since it's, as we talked on the last one, delta y over delta x. My y is my height, so it's 0.93 centimeters of height over 1 centimeter of arm span. So for every, come over here, so what this is saying is, on average, for each increase of 1 centimeter of arm span, there corresponds, or there's associated, or let's just say, since we're already saying on average, I can say on average there is an increase of 0.93 centimeters of height. Okay, you got to have that on average part, because it is just kind of an average, loosely speaking here. Okay, it's just a trend. All right, there you go. We'll pick up 27 on the next video.